This sample example problem goes along with 7.4 example 11, finding function values of s over 2 given information about angle s. So here we're given the cosine of angle s equals -3/7, and it also tells you that s, not s over 2, angle s is in between pi and 3π/2, putting angle s in quadrant 3. But if we're tasked to find all these half angles, we need to find out what quadrant s divided by 2 is. So the first thing we're going to do is we can write down our restriction information here. S, angle s, is in between pi and 3π/2. Well, I want to solve for s divided by 2, not s. So I need to divide all three intervals by 2 in order to put s over 2 in between these. Well, if I do that, if I divide this middle region by 2 and this region by 2, I have to divide 3π/2 by 2, and 2 times 2 is 4. So now I've found what quadrant the angle s divided by 2 is in. It's in between pi/2 and 3π/4. So it's in the top part of quadrant 2. So s over 2 is in quadrant 2. That's important to know, because if s over 2 is in quadrant 2, then that means the sign of s over 2, because it's in quadrant 2, is positive. The cosine of s over 2 in quadrant 2 would be negative, and the tangent of s over 2, because it's in quadrant 2, is negative. That way you can double check your final answers, make sure you don't drop a sign. So first thing we're going to do, find s over 2. Well, obviously if you're trying to find s divided by 2, this looks like a job for half an angle formula. And the half angle formula, remember sine, we're going to take the positive root, is the square root of 1 minus the cosine of angle A, take a look at your formula sheet, divided by 2. Keep breaking that pencil lead. 1 minus cosine A, and we're given, not cosine A, but we're doing s. All right, so same difference. So cosine s. Cosine s is -3/7. We were given that, so -3/7 plugs right into there. Got a little darker. All right, so this then becomes the positive root, and we have, well, 1 is going to come disguised as 7/7 because our denominator here is 7. 7/7 minus a minus 3 is 7 plus 3, or 10/7. So again, 7/7 plus 3 is 10/7. This is all divided by 2, which is the same as multiplying by the reciprocal. In other words, I'm going to get 10/14, but I can also divide the 2 into the 10 first, and that means I'm going to get 5, square root of 5/7. I want to rationalize that, multiply top and bottom by the square root of 7 over square root of 7, and I get the square root of 35/7, and again that's positive because it's a positive for sine of s over 2. So sine of s over 2 is exactly square root of 35/7. All right? There's part 1 of our 3-part solve. Part 2, it wants us to find cosine of s over 2. Cosine of half an angle is very similar to the sine of half an angle. Remember that cosine of half an angle is negative, so we're going to use the negative root. Might as well get that right off the bat. And the formula, instead of being 1 minus cosine of the angle, it's 1 plus cosine of the angle, and again our angle is still -3/7. -3/7. 7, and this is all over 2. Again, 1 is going to become disguised as 7 over 7 plus negative 3 over 7 is 7 minus 3, or 4. 4 over 7 divided by 2 is the same as multiplying by the reciprocal, and like before, I can divide first. So this is the, don't forget the negative sign here. I almost forgot that negative because this is negative. Let's write it over here. This is the negative square root of 2 over 7, but I want to multiply top and bottom by rad 7 over rad 7, and I get negative square root of 14 over 7, negative square root, already rationalized, negative square root of 14 over 7. That's the cosine of s over 2. Now, we could do tangent of s over 2 the hard way or the easy way. Let's opt for the easy way, because you can plug and chug in the formulas, but isn't the tangent of s over 2 going to be the same as the sine of s over 2 divided by the cosine of s over 2? That's the definition of tangent, right? Tangent is sine over cosine. The angles have to all match. So what is the sine of s over 2? Well, that's what we solve for up here. It's rad 35 over 7, square root of 35 over 7. And the cosine of s over 2 we just solved for, it's negative square root of 14 over 7. But of course, instead of dividing by cosine, let's multiply by the reciprocal. And the reciprocal of negative 14 over 7 is negative 7 over square root of 14. Sorry, I said 14. Square root of 14, right? Now, what makes this particularly fun is that the 7s divide out. This is a positive times a negative. Remember, positive times a negative. Tangent has to be negative. So we're going to have negative rad 35 over rad 14. We're not done yet. Rad 35 over rad 14. Take a look at those two numbers, 35 and 14. What do they have in common? They've got a 7 in common. So I could think of this as square root of 7 times square root of 5, and I could think of this as square root of 7 times square root of 2. So the square root of 7s divide out, and I'm left with negative rad 5 over rad 2. I have to rationalize that, so I'm going to multiply top and bottom by square root of 2 over square root of 2. I'm going to get negative square root of 5 times square root of 2 over rad 2 times rad 2 is 2. My final answer is going to be negative square root of 10 over 2. And that's what our negative square root of 10 over 2. That's the tangent of s over 2. We found all three problems. There you go.